Section 6.3 Sampling Distributions and Estimators. Key concept. We now consider the concept of a sampling distribution of a statistic. Instead of working with values from the original population, we want to focus on the values of statistics, such as sample proportions or sample means, obtained from the population. Now we have the general behavior of sampling distributions. When samples of the same size are taken from the same population, the following two properties apply. Sample proportions tend to be normally distributed. The mean of all the sample proportions is equal to the population proportion. So let's take a look at what this looks like as a figure here. So if we take a look at the first one, which is the proportions, we have our sample. We have the sampling procedure in which you randomly select n values and find the proportion for each sample. So you have sample 1, sample 2, and sample 3. And then the population proportion is p. And then we get the sample proportions. And then when we look at this distribution of sample proportions, we can see that the sample proportions tend to have a normal distribution. If we take a look at the means, same thing, we have our sample. The sampling procedure, we randomly select n values and find the mean for each sample. Sample 1, sample 2, sample 3. And again, the population mean is mu. So the sample means, you have the sample mean for sample 1, sample 2, and sample 3. Now the distribution of sample means, as you can see here, the sample means tend to have a normal distribution. And then the variances. Very similar here. We have the sampling procedure. Again, we're randomly selecting n values and find the variances for each sample. And the population variance is the following. Again, using those samples, you find the sample variance for each one. In the distribution of sample variances, we see that the sample variances tend to have a skewed distribution. So, a sampling distribution of a statistic. The sampling distribution of a statistic, such as a sample proportion or sample mean, is the distribution of all values of the statistic when all possible samples of the sample size n are taken from the same population. The sampling distribution of a statistic is typically represented as a probability distribution in the format of a probability histogram, formula, or table. Now, the sampling distribution of the sample proportion is the distribution of sample proportions, or the distribution of the variable, which is the point estimate, with all samples having the sample size n taken from the same population. The sampling distribution of the sample proportion is typically represented as a probability distribution in the format of a probability histogram, formula, or table. So what we need to do is we need to distinguish between a population proportion P and a sample proportion. So here are your notations for proportions. X represents the number of successes. N represents the sample size. Capital N represents the population size. P hat is X over N, which denotes the sample proportion. P is X over capital N, which denotes the population proportion. And then here we can see that P, this symbol, is pronounced as P hat. So when symbols are used above a letter, as in the sample mean and the sample proportion, they represent statistics and not parameters. That means that they are samples, not the population. Now, the behavior of sample proportions. The distribution of sample proportions tends to approximate a normal distribution. Now, sample proportions target the value of the population proportion in a sense that the mean of all the sample proportions is equal to the population proportion. The expected value of the sample proportion is equal to the population proportion.